Have you ever eaten Asian food? If you have, then you've certainly eaten soy sauce. There are many different varieties of soy sauce from many different countries in East Asia. We're probably most familiar with the sauces from China. These come in two main types: dark, which is mainly used for dipping or sprinkling on food, and light, which is more often used as a cooking ingredient. Have you ever wondered what it's made of? It starts with these: soya beans. They are boiled to soften them and then mixed with grains such as wheat, barley or rice, and they're also mixed with brine. They're then fermented using a particular variety of Aspergillus mold. One of the reasons soy sauce is so popular is that it gives food a big hit of umami. Umami is the fifth basic taste after sweet, sour, sugar and salt, and it's a sort of savoury flavour. This umami flavouring is due to the presence of amino acids, particularly glutamic acid. In fact, the salt, monosodium glutamate, is often used in Chinese cookery to enhance flavour in the same way we might use salt. In the case of soy sauce, we will use thin layer chromatography, or TLC, to analyse which particular amino acids are present. You will all be familiar with paper chromatography. TLC works in the same way to separate substances according to their solubilities and how they react with the material the plate is made of. TLC uses a thin layer of silica or alumina on a plastic backing. Here, we are going to use TLC to investigate the amino acids present in three different types of soy sauce. We have a dark soy sauce, a light soy sauce, and a sample from some supermarket sushi. Take the TLC plate and lightly draw a pencil line about 1 centimetre from the bottom. Apply a very small spot of your soy sauce, only a couple of millimetres or so. If your plate is wide enough, you can put further spots along the plate. Once you've applied the spots, place the TLC plate in the beaker so the bottom just dips into the solvent. Now cover and wait. Once the solvent has reached a good height, remove it and let it dry. The amino acids are not visible to the naked eye, so we need to use a reagent which will enable us to see them. The reagent we use is ninhydrin. It is available either as a spray or as a solution you dip the plate into. The solvent is harmful, so this should be done in a fume cupboard. We let it dry again, but still there is nothing to be seen. This is because the reaction needs heat to work. We place the TLC plates on a hot plate at 60 to 70 degrees. You can now see that spots have appeared at different points on the TLC plate. Each spot represents a different amino acid. You can see that the three samples we used have slightly different patterns of spots, meaning that they contain some different amino acids.
My name is Dr. Jonathan Wilkin and I'm from Abertay University and I'm a senior food technologist. As a food technologist, you have to be able to do as much as possible because you have to apply your trade to most things. So it's anywhere from product development, consumer studies, and technical analysis within labs. Thin layer chromatography is a really important part of the food industry. It shows you the basis, the foundation of how chromatography works. And how it works is the size of the molecule and how fast they move. And that's really important in the food industry because we can look at things like aflatoxins and other toxins using HPLCs, or we can look at lipids and fatty acids with using gas chromatography. So they use the same principles as your TLC plates. But they're in a much more advanced way, which is how we use them in the food industry. My career path for where I am, it started off as doing home economics and chemistry at A-level, and then I went off and did a food science and technology degree, and then I went into industry and worked for 3 years, and then I came back into academia and did my PhD in food chemistry. And then I got a job as a senior food technologist at Abertay University. In Scotland, the biggest problem that we've got in the foreseeable future is sugar, and how to reduce sugar down and keep a product that tastes good, has the same structure. In the food industry as a whole worldwide, we're going to have more protein because it's the one thing that will keep the whole world fed. So protein is a really important thing. And proteins and sugars are all chemicals, so chemistry is really important. So get your chemistry, get your science in, and we need people with the chemistry brain to help us in the food industry, and they're the people that will solve the big issues that we have.